So this is lesson 4. This is module 5. On the board it says right now, a discrete function is your x values must be integers. No fractions, no decimals, nothing. So here's my example. I don't know who or what ELA teacher, let's say Ms. Gilman, Ms. Kirchhoffer, Ms. Martin, asked you to write a paper. So each student must write 3 pages. Okay? That's pretty self-explanatory, right? Brock, how many pages would you have to write?
3.
3. I can make a graph based off of this. Okay? My graph is going to say students and pages. Okay? We know that there's 0, here's 3, here's 6, there's 9, 12, 15, 18. Bless you. 1, 2, 3, 4, 5. Okay. So, Madison, how many pages does one student write?
3.
3 pages. So I could graph that one student. Ryan, if 2 students turned in their work, how many pages did 2 students write? 6, because each student wrote 3 pages, right? Okay. What about 3 students? How many pages did 3 students write? This is the class participation part.
9.
How many?
9.
9, because you did 3 times 3, right? Which means 4 is going to be 12, 5 is going to be 15. So let me make these points a little bit bigger so we can see them. Okay. Here's my question right now. Is this a linear equation? So based off of what's right here, is this a linear equation? I need hands, yes or no, why or why not. And I see people nodding, I see people shaking. Emily.
No, because if you were to draw a line through it, it would be straight, and if you were to keep going,
Okay, good. So, Ms. Armstrong, can you hand Justin my meter stick or yardstick? Justin will hand, and we'll just keep passing it up because I'd like that. Yeah. Okay, so what you're saying is, let me make sure that I understand this. You're saying that you would like me to connect these dots. Yes? Mariah, you're saying yes as well? Like you had a very emphatic head nod, yes?
yes.
Oh man, you're so wrong. Here we go. Okay, this is what you've told me to do. I agree that I could draw a line through those dots. I disagree that I should. So let's think about when we've done graphing equations, what has that line actually meant to us? What has that line actually told us it was? Everywhere on that line had to be what? It starts with an S. Kind of solve.
I heard somebody say it. Say it. Just everybody on the count of 3. Say what you think it is.
Oh,
1, 2, 3. I heard some people say it. It sounded
Did
like.
you just make up a word? Because that was awesome.
I heard some people say solution. Who said solution? Put your hand up.
Nice. So this table, good. Everywhere on this line is supposed to be a solution. Okay, does everybody agree with that? Okay. Ms. Armstrong, can you come here? This is going to be your favorite day ever.
No magic tricks, Mr. A.
I'm going to give you this. Ms. Armstrong's going to be very excited about this. So,
Ready?
right now, stop. You settle down there, killer. So right now, we're counting by 1 student, 2 students, 3 students, 4 students, 5 students. The way Emily has told me to do this is that 1.5 students can write 4.5 pages. Because that's what that says, right? So does that mean that Mrs. Armstrong's back there, cutting me in half, and half of me is going to write the paper? Like, you're having, okay, I don't know, stop it. I don't like it. I don't trust you. Can we have half of a student? Like, are we going to say, okay, 1.25 of a student are going to write a paper? No. So we cannot connect the points. Are you distracting my students?
Yes. Sorry, a little bit.
So,
No, I said a little bit.
this is a discrete function. Discrete meaning that we can't count by fractions. I can't say there's going to be 1 1/4 student. Okay? There's 1 student, there's 2 students, there's 3 students. There could be 0 students, but there cannot be a half of a student. Okay? That is a discrete function. Discrete is never linear. A discrete function will never be a linear function. We cannot write a linear equation for something that is discrete.
So if I were taking notes right now, which Mr. H just gave us some really good information, under discrete function, I would write never a linear function, not linear, something to that effect. That you know a discrete function is not going to be a linear function. Write it down. You've got that information on your papers.
So my question that I ask myself to help me with discrete versus not discrete is, can I have a fraction of something? Oh. Did you make me drop that? Maybe. So let's think about something that I can have a fraction of. My favorite way to go is time. Okay, because we can have 1/10 of a second, 2/10 of a second, half of a second, a full second, a minute, 30 minutes, an hour. There are lots of fractions within time. Okay, let's go with time versus miles. Okay, I get in my car. We're at 0, 0. Here's 1 hour. Here's 2 hours, bless you. Here's 3 hours, and I'm driving 60 miles per hour. Okay? So at 1 hour, I've driven 60. At 2 hours, I've driven 120. At 3 hours, I've driven 180. Can I connect these points? Why or why not? Can I connect these when I'm driving? You think no, Brock. So here's my question for you, Brock. Do I only have to drive? Oh, we're not going to see this. Do I only have to drive exactly 1 hour?
No.
Could I drive 30 minutes?
Yeah.
Oh, so 30 minutes, if I was driving 60 miles an hour, I'd be there, right?
Mm-hmm.
Could I drive for 30 seconds?
Mm-hmm.
Oh, yeah, I mean, I could. Do I want to? No. Could I drive for an hour and a half?
Yeah.
Could I drive for an hour, 0.55? So with time, I'm going to have the dots connect. Why? Because time can be broken down into parts. This is a non-discrete or not a discrete function. Are all non-discrete functions linear? No. But if you graph it, you're going to be able to tell whether it's linear or not. The key is knowing, can I break something down into parts? If I can break it down into parts, our class is 58 minutes. Well, that's 58 single minutes. That's 126 half minutes. And I could keep breaking that down. We can break this down. We can't break down one whole student. Everybody with me? So, go to, that should be there already. So you're on that front page. You are telling me whether it is discrete or not discrete. I would like you to do A, B, and E. Talk it over with your table. You're telling me whether it's discrete or not discrete. Have a reason why. So you're talking it over with your group. So A, B, and E. You're telling me discrete, not discrete, and why.
Is discrete. Because you can break it down. No, do you agree? But in discrete. I would say it is discrete. No. Well, and then B, you can break that time, can't you, of Sammy's fever. Because you can break it per hour, per half an hour, per 5 hours, per 2 hours, per minute, per millisecond.
This or this?
So I would say it's discrete too. Do you agree?
Cans of beans. Yes, sir.
Because you can break. What do you say?
So, can we break down a can of beans? No, we have to buy 1 can, 2 cans, 3 cans. That's what discrete is having that whole number that in it.
What?
So we have A, B, and
Discrete, yeah.
no, no C, just A, B, and E. Just 3 problems. A, B, and E.
Three green markers.
I would say not discrete, which that was a little bit confusing. What do you?
Okay, so I want to hear the explanation as well. So you've just talked it over with your partners. What is letter A and why, Megan? Is letter A going to be discrete or not discrete, and why? So, wait. Let me read it. Let's make sure. I'm going to give you a little bit more time to talk to your group if you need to. The function that assigns to each whole number the cost of buying that many cans of beans in a particular grocery store. So is it going to be discrete or non-discrete? Why? Yes and no. Let me give you a little example, okay? So, how many have seen like the hot dog packs come in 8, but the hot dog buns come in 6? Can you open up a bag, rip out 6 of them and be like, no, excuse me, I just want these 2? Can you say that to them? Well, I mean, you can, but you're still going to pay for the full bag of 8. Can I walk into the grocery store and be like, man, I don't really want this whole can of beans. I'm going to open it up, dump half in my pocket, and only pay for half of it? I'm going to pay for the whole can, right? We can't split that can into smaller parts when we buy them. So because our can of beans has to be this steady increase by an integer, it's going to be a discrete function. Everybody with me? What about letter B? It says the function that assigns to each time of day, one Wednesday, the temperature of Sammy's fever at that time. So, yesterday was Wednesday. Let's pretend today's Wednesday. So Sammy's going to have her fever checked now. Okay, I'm done. So, can we break down time? Absolutely. We can always break down time into smaller and smaller and smaller parts. So, Nicholas, would this be discrete or not discrete if we can break it down into smaller chunks?
I would say it would actually not be discrete.
Exactly. It would not be discrete. Anytime that we can break it down into smaller parts, it is not discrete. So for A, you should have discrete. For B, you should have non-discrete. Anytime that we're dealing with time, it will be non-discrete. That's a key. If it says we're dealing with time, it's not discrete. Okay, Noah. Noah's like, man, I hate you so much. I know, it's all right. The function that assigns to each moment in the year 2015 my height at that moment. So my question to you is, what are we dealing with when it's talking about moments? Are we talking about students and pages? Are we talking about miles? Are we talking about time? What are we talking when we say moments? Time. So if we're talking about time, immediately that should be a clue for you. Is it going to be a discrete function or a non-discrete function? Because why? What can we do with time? We can break it down. Does that make sense? Anytime that you can break it down, it will be non-discrete. Do I think that's a realistic question? You're going to check my height throughout 2015? No. I'm going to pretty much stay short. Like that. No.
What was your age?
Reagan, we were like this. Oh, way over here like this. Enjoy that sucker. Go ahead. Questions on this? Are we starting to understand the difference between discrete and not discrete? Go to example 3. It's on the back side. Go to example 3, please. So read along, circle things that you think are going to be important here in a second. I'm going to read it with you, but I'd like you to highlight, underline, circle things that you think are going to be important. You have just been served freshly made soup that is so hot that it cannot be eaten. You measure the temperature of the soup, and it is 210 degrees Fahrenheit. Since 212 degrees Fahrenheit is boiling, listen carefully, there is no way it can safely be eaten. Because second hour said, I could eat it. Right, great. You probably could. Boiling means it's that bubbling stuff. Yeah? You probably could eat it. You'd be hurting. Okay? So it can't be safely eaten. 1 minute after receiving the soup, the temperature has dropped to 203 degrees. Here's part of the key, so this is what I'll be underlined. If you assume that the rate at which the soup cools stays constant, write an equation that would describe the temperature of the soup at any one time. So here's what I want you doing first. Before anything else with your group, I want you to determine what the constant will be. So talk it over with your group. After reading this, try to figure out what will be the constant of change. So go ahead and read it. Tell me what's going to be the constant and why. I'm big on the why part.
Because it's the only
Emily, did you just say what I think you said?
Probably.
Did you just say the equation's going to be y equals
No, I
soup
said
x?
you're not.
Well, well, I'll teach you guys well. Y equals soup x.
How are we gonna figure out what the constant is?
Okay, so it's gonna have to be the temperature, right? What about the temperature? Yeah.
I should be hearing some nice dialogue.
It happens over 1 minute. Listen. So between the two of you, we've got that it has to be the temperature. How much the temperature changes over 1 minute?
So what you guys come up with?
How much the temperature changes over 1 minute?
So I want the constant of change. What's changing so far? What's the only
Where did you get
the
seven?
degrees?
Recap is Tanya Pierce, call room
So what's
103,
been the
please.
change in degrees?
Say that again.
Yes, temperature, but what's been the change?
So, but tell everybody how you got that, because I agree with you, you are absolutely right. But
Okay, so
where
what
the
was our
numbers that
starting
you
point?
used to get that information?
Okay. What's the change? What does it change to? So it's going from 210 to 212?
No, 203.
Oh, so it's going from 210 to 203.
Not
By how
not
much?
207, it's just 7.
Why,
So you use,
So are we using the 212 or are we using the 210?
2 degrees, right?
Because that's what?
The ending temperature.
Where was the
after
soup
one
at?
minute was 203
Oh, okay.
degrees. And the
So how?
change
Oh, so
for
it's
1
changing
minute
7,
was
up or down?
7 degrees. So write that down.
So I wonder what that's going to
Write
be.
that down. That's great
Positive
information.
and negative?
So what's your constant?
So what do you guys think?
Did it go up 7 degrees or
So
did it go
what's the
down?
starting
It'll
point?
be, it'll be serving that kind of.
Where did the soup start
I
at?
forgot what we said, the change.
Okay? What's the change?
Would be.
It dropped by what? Oh, so if that stays constant, what's it going to keep dropping by? So do we have a constant now? This is example 3, right? So, I heard some great things, I heard some not so great things. So first off, okay, back to me please. The question's eventually asking us to write an equation, okay? So, if we're writing an equation of a function, what equation are we using always when we're writing the equation of a function? It's the only equation that we use. Y equals mx plus b. Very good. This is slope-intercept form. Y equals mx plus b. So to write an equation, what two things do we need? To write this equation, what two things do we need? Say it. M, which is my constant. That's the constant of change. And my b, which is what? Say, I heard it. The starting point. Okay. So now let's think here. I'm going to do this. You do not have to draw this if you don't want to, but it's not a bad idea. So I've got time, and I've got temperature. Well, we're dealing with my soup. Where does my soup start at? Because there's some extraneous information in this problem. Extraneous meaning too much. Where does it start at? So it's starting, before we start counting down, at 210 degrees. Does everybody agree there? Okay. Because we are writing an equation in slope-intercept form, that means the graph, if we graphed it, would be a what type of equation? Starts with an L. Linear equation. It would have to be a straight line. So, let's think about this. I don't need any other numbers yet. I just want you to think about the line. Will the line of the temperature and the time be going up or down? Cameron, what do you think? Down. Why? What's happening with the soup? What is? The temperature's going down. So at 1 minute, we know it's at 203 degrees. So if I start connecting these, the line would be going downhill. Is everybody with me so far? If the line's going downhill, immediately we should know something about m. We should know something about our constant. What do we know if it's going downhill, Maverick? Lydia? It's going to be negative. If my line goes downhill, Maverick, it's going to be what? Negative. Can we see this? Like, I don't know. There's so much stuff going on right now. Okay. It's going to be negative. Well, let's think about the information that we know. It says, starts at 210, after 1 minute it drops to 203. Then we're going to assume that that stays constant. I heard a lot of people trying to say, well, it's dropping 9 degrees, Mr. H. Well, that's part of that extraneous information. 212 degrees tells me the boiling temperature. Do we care that it's boiling? No. We care that it starts at 210, it drops to 203. How much did it drop, Ellie? From 210 to 203. 7 what? 7 degrees. So after 1 minute, it drops 7. It's going to stay constant. So after 2 minutes, it drops another, what? 7 degrees. So my constant isn't 7, it's negative 7. Could I put it negative 7 over 1? Sure, because our slope's supposed to be a fraction, but we're not really graphing this because we're not even in graphing yet, we're just in functions. So I'm just going to leave it as negative 7. Michaela, you told me what b was. What is that? starting point. So now I ask again, what do we think the b is going to be for this function? Where did we start in this function, Ava? Huh. So I've broken this down. Does everybody see how I said, okay, can I find my constant? Yeah, we were able to do the subtraction. We were able to look at it visually and say, oh, I'm seeing that it's dropping. How? Because the temperature's dropping. My line would keep continuing to go down because the temperature's not rising. So that's how I got a negative. Oh, we already graphed it that it's starting at 210. Can we write an equation now that we have m and b? Can we? Carly, what will my equation be now that I have m and b?
Y equals -7 plus
Negative 7.
x plus 210.
This is a very specific example of how we find constant. How have we been finding a constant on all of our other graphs? What have we been dividing to find our constants? So for lesson 1 in the homework that you turned in, what have we been dividing? Megan? Y divided by x. Okay. So now we have something a little bit different because it's giving us several different numbers that we had to actually calculate. So now we have this equation. So somewhere on there, because this is going to absolutely help you, I would write down these questions. So here's question A. Question A, even though it's not on that paper, is discrete / not discrete, question mark, y, question mark. So with your group, you're going to tell me, is it discrete, is it not discrete, and why? Will the temperature be below 150 degrees after 5 minutes? And C, make sure I have this. What is the temperature after 14 minutes? Okay, so as your group, is it discrete or not discrete, and why? So, will this be discrete or not discrete? Why? Will the temperature be below 150 degrees after 5 minutes? Please don't just put yes or no. Don't guess. Show me some work. Tell me why you think that. And then letter C, what is the temperature after 14 minutes? We are still using example 3 as our whole basis for these 3 questions. Go ahead. So I would write these down because these are part of your notes. I'm going to enter in your homework so that I can hand back these lessons to you because I want to make sure that you have lesson 3 as well. Maybe if my computer turns back on. There we go.
It's discrete. It's the discrete time.
It's not discrete.
Oh yeah, it's not because of time. Why? Because of
Okay, folks, so I'm already seeing some that don't have names on them. That will make it very difficult for me to put in a score for you. So if you don't get your homework back, you'll have to be like, Mr. H, I turned it in, but my name is not on it. And I'll say, okay, what's your name? Right, Reagan?
What?
Yep, good. So say again? I can't see. Which value, actually? So where would I substitute my 14 in? Make sense?
no,
I'd share that with Brian too.
no it won't. It'll be 197 at 5 minutes because kept taking 203 minus 7. What is the temperature after 14 minutes? So,
What's 7 times 5? That's 30. No.
yeah, that's what I thought. Now it's after 14 minutes. Or what will it be?
They don't know if I have it or not. They don't know if I have it or not. People talking.
7 times 98.
You're on a minute and a half clock. Let's hear your good conversations, please.
I got 108. I don't know if that's right, but
Honey, it's the same grading scale we've been using all year. If you turn it in, it's good. If you don't turn it in, it's the same. We're not changing anything as far as how we score.
I feel like it's because I'm not good when I have to
I know.
Okay.
I asked Mr. H, and he said the homework was going to be based off if it was correct or not, so I don't know.
Okay, we haven't changed our scoring policy.
Can you go, Miss Armstrong?
Yeah.
Can I see my water bottle? What we're rolling out?
Miss Armstrong.
Yes.
Is that right? Because I'm not good when I have to do the carryover and stuff like that. I'm not good with that.
So 210 subtract 98. Oh, so this would just be 10 minus 8, so what would that number be? 10 minus 8 is
2.
2.
Yeah, but you have to make it 10.
No,
Is that?
and it is 10, sweetie. That's not gonna be a 9, because you're not regrouping from there.
That one needs to make that one.
This one's gonna be
Needs to
a,
make that one.
167.
What's your last name?
you're gonna regroup from this, this becomes a 0. This becomes a 10, it can stay at 10. 10 minus 8 is 2, right? This is a 2, but we have to make this 10, correct? So this becomes a 1, this becomes a 10. 10 minus 9 is 1. There you go.
I was off by 1. Is this right for
Okay, so let's go with the easy answer. Is it discrete or not, and why? Come on, I should see every single hand in here telling me, is it discrete, is it not discrete, and why? Ellie. Good. Hold on, I can't hear you. Give me 1 second. So it's not discrete because why? Because it, why? So the temperature continues to go down. It doesn't stay constant. What do you mean by it doesn't stay constant?
So, Mr. H, I'm actually having a hard time hearing, because we've got a bunch of people talking when we're not supposed to be talking.
So I'm going to say that it is going to stay constant because we have our constant, right? I agree with not discrete. What two things are we dealing with? Time and temperature. As soon as there's time, can we break that down into smaller parts? So once we're able to break it down into smaller parts, that's going to give me a non-discrete. But let's go a little bit further. Is it a linear equation? If it's a linear equation, is it going to be not discrete or discrete? Not discrete. Okay, does that make sense? So, not discrete because it's a linear equation. Not discrete because it's a function of time. Not discrete because we can break the x values down. So, will the temperature be below 150 degrees after 5 minutes? What are we going to do, Ava?
I multiplied 5 by 7,
Okay, and then?
and I got 35 degrees. So I subtracted 35 by 210 degrees, and I got 165.
I love what you did there. So here's option A. What Ava told me is she said, okay, 5 multiplied by 7 is 35. She then took our starting temperature, which was 210, subtracted 35, and then you got 175, right?
She said 65.
165? 570. It's gonna be 175. Okay, but I agree. That's correct. So will the temperature be below 150?
No.
No. Now, that's not where my mathematical mind goes. I understand and agree that that is a great way to do it, and most students have done it that way. As soon as I've written this equation, I'm going to use the equation. So the way that I would solve this is I have y equals negative 7x plus 210. What are my x values? Is my x values temperature or my x values time? Based off of the graph and the axes, what is time? X or y? X, right? So I'm going to use this equation and I'm going to substitute in my time. It's the same thing, except now I'm using the equation that's given to me. Okay? So same idea for what is the temperature after 14 minutes. Who thinks they know what the temperature is after 14 minutes? Who got this far? Go ahead. 112 degrees. I have no idea. Let's find out. Y equals negative 7x plus 210. You did y equals negative 7 multiplied by 14 plus 210, yeah? Something like that. You did 14 times 7? 14 multiplied by 7 is 8. Carry the 2. That's 798. So while I have y equals negative 98 plus 210, so now I'm going to subtract 210 minus 98. I'm going to borrow, that's 10, that's 10, that's 2, that's 1. It does give me 112 degrees. Very good. Questions on how I use what's given to me? Now, why is this one different than what we've been dealing with? Well, this is different because it's giving us a starting point that is not 0. Most of the things that we've been doing are like miles and gallons, right? If I don't buy gallons of gas, I don't pay any money. If I buy 1 gallon of gas, I pay $2.90 or whatever it happens to be. When we don't have a starting point to find m, you're taking y divided by x. That's going to be an important part for your homework. Okay? Let's make sure I don't have any other examples to do. I don't think I do. But that's why I highlight stuff back here. Where did it go? There it is. We do have one more example, but I want to keep on going. We have 10 minutes, so yeah. Okay. Your homework. Thank you. So you should be doing these on a separate piece of paper. I am telling you that for all of them, that's your hint. So you are at the homework, the problem set. You are doing number 1, letters A, C, and D. So number 1, you are doing the letters A, C, and D. Number 3, you are doing A, C, D, and E. And number 4, you are doing A, C, and D. That's 10 questions. I'm telling you right now, letter A, you will need to go back to lesson 1, lesson 3. I'm going to keep circling that because it's going to ask you to write an equation, which means you're going to have to find a constant. You're going to need that for letter A. Get started. Homework.